So today we're going to talk about exponential and logarithmic equations. We're actually going to kind of review exponential equations. We've already dealt with solving them a bit, but we'll do a quick review so that will lead in nicely to logarithmic equations. So just a reminder, an exponential equation contains one or more expressions that have a variable as an exponent. So if you look down to example 1, you can see 9 raised to the power 8 minus x equals 27 raised to the power x minus 3. That would be an equation that contains a variable as an exponent. Okay, and there's two ways to solve them in general. The first way is the way that we have already done, and then if b of x equals b of y, we know that the exponents can be equated. Okay, and we already spent a decent portion of time solving those. Now we're going to move into and deal with ones that you may require logarithms to solve. So if they can't get the same bases, like example 2, where you have 4 to the x minus 1 equals 5, we can't get them to have the same bases. So in that case, you're going to need a logarithm, and you could either take the log of both sides, and or, depending on the problem, convert to logarithmic form. So a lot of what we've been doing with practicing to convert between exponential form and logarithmic form will become useful here. Okay, so I'm confident that you can do example 1, and I'll ask you to go ahead and try that example. We'll talk about the answers tomorrow during class. We're going to take a look at example 2, though, because that one we can't really get the bases to be the same. Okay, so if that's the case, then we can take the log of both sides, or we can convert to logarithmic form. So if I take 4 to the x minus 1 equals 5, and I want to convert that to logarithmic form, that would be log base 4 of 5 equals x minus 1. Then I'm going to use my logarithmic properties. So that's why we spent some time today talking about how to condense or expand or use the change of base law. So this I can re-express as log base 10 of 5 over log 4 equals x plus 1. Then, since I have it in log base 10, I can use my calculator, and I'll evaluate what log 5 is divided by log 4. Control 10 to the x gives us our log, and then we are going to just put into the position here, and we said log 5. You may want to press enter here and then divide by, or you could put it as a fractional value. So I put that in, and I get 1.161, let's say. So therefore, x is equal to, or approximately equal to, whoops, and I just recognized my mistake here. This should be a minus, so I'm going to make a correction there. And then I'm going to actually end up adding that 1 to both sides. And so I'll have 2.161 approximately equal to x. Okay, so using this, you could put it as a fraction, and you can put your log in here, right? So we can put the log 5 over log 4. And yes, you also have the option of using log base, but remember we said in class, you still have to show this step where you're doing the algebra to expand log base 4 of 5, okay? All right, so I'm going to ask you to go ahead and try the next 2 exercises, and then tomorrow we'll go through the answers for those. Okay, so if you want to pause and try those, that would be great. Okay, and then the next thing we're going to talk about is the logarithmic equation. And as you can probably guess, a logarithmic equation is an equation that contains a logarithmic expression. So it contains a logarithmic expression that has some variable included in there, okay? Which means that you're going to have to figure out how to isolate that variable. So there's a couple of different type of log problems. One might look like what our exponential ones did, where if you have logs with the same base, so if log, let's say base b of x is equal to log base b of y, if we have it in that form, then it's similar to how the exponential work. You can say log x equals, then you can say x equals y. Okay, we'll talk about a couple of different strategies for solving or dealing with logarithmic equations. So some methods that you might use is you might solve by using properties of logs, and or you may convert to exponential form. So as we said in class, logs and exponents are inverses of each other, so they undo each other. So if we need to undo a log, we need an exponent and vice versa. Okay, so let's take a look at the first example, which is a log base 6 of 2x minus 1 equals negative 1. Okay, and if we wanted, we can use the loop trick, i.e. converting to exponential form, to evaluate this, right? So that says 6 to the negative 1 equals 2x minus 1. And then we'll just go ahead and apply our exponent properties. So anything raised to a negative power is 1 over that power positive. And that's equal to 2x minus 1. And then we'll just use inverse operations. So plus 1 to both sides. And so then we technically have 7, 6 is equal to 2x, and then we'll divide both sides by 2. Okay, and then you're going to have fraction divided by fraction, so we're going to keep change flip, which means that you have x equals 7 over 12. Okay, now I would suggest that you check logarithmic equations, because remember, we can never get a negative answer in this space here. So where the 2x minus 1 is, we can't have a negative. So if you had an answer for x that made a negative in that position, then you would have extraneous solutions. And tomorrow during class, we'll talk about 2 ways that you can go about checking these. Okay, I'm going to ask you to go ahead and try example 3, letter B, and then I'm gonna go through the process, and then you can check your answer. So if you want, you can complete 3B, and then tomorrow we'll go through how to check graphically using the calculator. Let's take a quick look at 3C. So this one, in order to solve it, you first have to condense, okay? So you're going to have to take that expanded logarithm and condense it down, and then go to exponential form. So we have log base 4 of, subtraction means division, 100 divided by x plus 1 equals 1. And then from here, you'll want to convert to your exponential form. So then you have 4 equals 100 divided by x plus 4. And then you can go ahead and solve using cross multiplication. Okay, so I'll let you finish up 3C and try 3D. Tomorrow we'll do example 4 in class using the graphing calculator, and we'll also use the graphing calculator to check each of these problems.